All right. So, my name is Lucas Pontes. I'm a chief architect at Yukin Games, but tonight I'm your DevOps fairy. I don't know how I got doing this thing, but anyway, too late now. And so to get things started, we're gonna pretty much explain how we lost 1 million push notification messages. To give an overview, what is required in order to do a push notification? You need to get one information that is sitting on the device, send it up to your server. Once you have the information on your server, you can, using that specific token, send one piece of text plus that token information, and then the user will receive a push notification on their devices. So there are two things going on here. We need a client component, we need a server component, and at Yukin Games, we have two different teams taking care of that. Pretty important information here. The other thing is, as we are sending push notifications, we usually do this in bulk. So we're talking about sending the same message to millions of people, as long as we have their push notification token. So in order to do this, we use a project called Sidekick, which connects to Redis, and you manage the queue inside Redis. And this has a nice interface. You can go in there and watch everything being processed. You know how many messages per second are going and things like that. So far so good. You get a push notification from the device, send it up to the server. As soon as you want to contact the user, you push down one message using that push notification token. We also run events every Friday, and we start them around 3 in the afternoon, and those events are valid for the entire weekend. So these might be, come collect your cherries and you're going to receive 50% bonus on every time you collect, or they might be, there's a big discount on that $5.99 item is now $1.99. On a certain Friday, we pretty much send the push notification as we usually do, and this is a manual process because we like to play with the message from time to time. And it just occurred to a few of our devs that they were not receiving the push notification message at all. And at that point, we pretty much joked that everybody was running on a staging application instead of running on a production application, and that's pretty much why we didn't get anything. But we did have a few people on production not getting the message. And after starting investigating a bit further, we did figure out that we haven't been receiving messages for almost 3-4 weeks already. And okay, so that's failure number one. It was a Friday, so as every good DevOps, we decided to leave that for Monday. And on Monday, we started investigating the issue, and again, as every good DevOps, we figured out that this will never be my code. So this is probably a problem on the client. The client is not sending me this push notification token, and I'm just gonna push the work over there. And come Monday, and we actually start troubleshooting the entire setup. Our first guess was, well, they're not sending us a push notification token. And in fact, they were not. A while ago, one of our developers thought that as a sort of optimization, they would only send the push notification token the first time the user opens the app. It just happens that once the user opens the app, we don't have the user ID available because they haven't registered yet. So we had a bunch of phantom tokens that we had no idea who we should send a message to. This was pretty easy to solve, but we are dealing with Apple. As every single time you send an application to Apple, good luck. You have to wait at least 2 weeks for those guys to take a look at your app, figure out that you haven't changed a single line, and then they can approve and you can continue on. So it's a very lengthy process, and there's not much that we can do within that time frame. So around Wednesday, we did figure it out, we did patch the code, submit it to Apple, and from that point on, we pretty much said, we're done, this is it, we fixed the problem, let's move on. Except that, on that same Wednesday, we got a Redis blip. And we thought that, well, this is pretty weird, let's go check this out. As soon as we take a look at Redis, Redis had about 1,000 keys. And this is one Redis that it gets hit pretty hard. And in normal operations, we have close to 2 million keys on this Redis. What happened was, as messages were getting sent and scheduled for users, we didn't have the user's notification tokens set up properly. And we're still scheduling them, and Sidekick didn't know what to do with those messages. It's just rescheduling them for a later time. As those started to pile up, we actually ran out of memory on that Redis. And it's an in-memory database. You can imagine what happens when you run out of memory on an in-memory database. So we pretty much exploded Redis. And at that point, Redis restarted itself. As soon as it restarted itself, it came back with a complete fresh setup, a complete fresh memory, no lists, no sets whatsoever in there. The funny thing is, we didn't have a backup. Well, we actually did have a backup for this Redis, but a backup for a message queue, that's not very useful, especially when you're dealing with messages that are time sensitive. So that was one of our first mistakes right there. The other thing that was quite interesting is that as soon as we saw this blip on New Relic, we went back a few months and we saw the same blip in there. And back then, it kind of happened on a weekend, so we pretty much didn't care about it at all. We were like, well, we saw a blip, things come back up, great, let's move on. So it actually happened twice. And we happened to lose those million messages multiple times over a few years. It's just that it went unnoticed. And I think that there are a few takeaways here, and this is, I feel like a bit bad because it's sort of such a short story, but it kind of tells you that when we fail fast and we fail hard. And the thing here is, at that point we figured out that this is actually not about who we should blame here. Because we were doing a troubleshooting and we could have gone about it saying, you know what, you didn't do the proper troubleshooting here and you just figured out that you pushed the problem on somebody else, and in doing that, you just didn't solve the problem altogether. So we're not about blaming people on who did what, and it's a really delicate position in DevOps because usually, most of the time, you are the one that goes and figures out what is broken, and nobody likes to be that guy. The other approach that we can take is we actually learn and improve with this, and in doing this, just working together and figuring out what needs to be done to get things properly set up again, we get better at doing what we do, and I think that's what we need to take away from this. The other interesting part here is that Sidekick does have an awesome web interface. We can go in there, see all the messages, see how it's processing, the number of workers. It's like good stuff, but monitoring is not alerting. You can go in there and see how many messages per second you are processing. This is pretty cool, but can you receive a message when that number goes above a certain threshold? If you don't have that set up, you don't have alerting. The only thing that you have is a nice interface. This is something that we're really trying to get better at, pretty much separate what is monitoring, alerting, what is graphing, and where each tool actually fits in all this model. The third thing is, we can only improve what we can measure. We had no ideas how many push notifications we were sending, how many push tokens we were receiving from clients, and during this entire process, we actually had to go and figure those out. So we ended up adding tons of instrumentation to our code, and today we are at a way better position to determine when things are going out of normal. And that's pretty much my story, and thanks